Welcome back, everybody. Yay, math. We are finishing chapter 2 with our section 2.4 notes on writing quadratic equations. So up to this point, again, similar to the way that we were talking about in section 2.0, we've been given the equations in standard form, vertex form, or intercept form. And we've been graphing them, finding their vertex, axis of symmetry, and all that good stuff. So now we're working backwards. Now they're going to give us information, and we need to be able to fill in the equation. So when we are filling in vertex form, we have to be able to replace A, H, and K. Everything else about that form stays exactly the same. If we have intercept form, then we are filling in A, P, and Q. Our steps for finding A. So the first thing we're going to have to do is to find A, because they'll give us enough information to fill in the other stuff, but we're not going to know what A is. So our steps for finding A will be, if we have vertex form, plug in X, Y, H, and K. If we have intercept form, then we plug in X, Y, P, and Q. Step 2, you do the math to solve for A, and then to give the equation, again, if you have vertex form, you're going to plug in A, H, and K. If you have intercept form, you will plug in A, P, and Q. And then those would be our equations. So here we have a parabola for a human cannonball. The human cannonball was launched over here at a height of 15 feet, got to a maximum height of 35 feet, 50 feet away from the cannon, and then we don't see the ending over there. So it's asking us to write the equation right here. We're not going to worry about the height of the net right now. So we're just going to start with writing the equation. So let's talk about what we're given. We're given a point, xy. And this 50-35 is a special point because it's the vertex, which means that's hk. We are given the vertex, so we will use vertex form. A x minus h squared plus k. So remember in our steps we said the first thing we're going to do are plug in h, k, x, and y. So we labeled our y as 15. A we're looking for. X is 0 minus h is 50. And then plus k is 35. So I need to work over on the right side first. 0 minus 50 is negative 50. Negative 50 squared is 2,500a. Now we can solve to get a alone. Remember, we start with subtracting 35 over to its like term. And we get negative 20 Let me change the color of this pen. Negative 20 is equal to 2,500A. And then divide both sides by 2,500. And we're going to go ahead and leave these in fraction form. So we're going to reduce the 20 and 2,500 to get A is negative 1 over 125. So now to write our equation, remember we fill in A, H, and K. So this equation is y equals negative 1 over 125 times x minus 50 squared plus 35. This next equation, again, is similar. We're looking at what they gave us. They gave us an ordered pair of 0, 20. And then they gave us that special ordered pair of the vertex here at 25, 30. So I'm going to label that HK and this XY. Start with plugging in HK, XY. So we have 20 is equal to A times X is 0, H is 25, and K is 30. Follow your order of operations. We'll do 0 minus 25 first is negative 25. Negative 25 squared is, sorry, erase this out. Negative 25 squared is 625A. Now we can go ahead and move our like terms over to the same side. We're going to subtract the 30 and get negative 10. Divide both sides by 625 to get A alone. Reduce the negative 10 over 625 to get negative 2 over 125 for A. We write our final equation only plugging in A, H, and K. X and Y have to be there. So we have Y is equal negative 2 over 125 times X minus 25 squared plus 30. And that is the equation for this line. Our next graph gives us an ordered pair here, and then these are crossing the x-axis. So that means they gave us x-intercepts. And we're only going to focus on this part A for right now. And we're only going to talk about write the equation, write the function, write the equation. So they gave us an x and a y in this ordered pair here. And then down here, they gave us P and Q. The x-intercepts, remember in intercept form, are P and Q. It does not matter which one is P or which one is Q. So filling it into our formula, we have x minus P times x minus Q. So we know y is 9.6. Looking for A, we labeled x as 0. Minus, we labeled P as 4. Again, x is 0. Minus, Q is 24. 0 minus 4 is negative 4. 0 minus 24 is negative 24. And multiply those guys together, we get 9.6 is equal to 96A. So we'll divide both sides by 96, and we get 0.1 is equal to A. So to write our final equation, remember we fill in A, P, and Q. So we have y is equal to 0.1 times x minus 4 times x minus 24. And that is our equation. All right. Our last example here, again, we're looking at, they give us an ordered pair, call it xy. Then they give us these two special points again of P and Q, because they are x-intercepts, they're touching the x-axis. So we start with filling in what we know into our equation to solve for A. So we have 6.3 is equal to A, x is 0 minus P is 6, x is 0, Q is 21. 0 minus 6 is negative 6. 0 minus 21 is negative 21. Go ahead and multiply that stuff together. Negative 6 times negative 21 is 126A. Divide both sides by the 126 to get A alone, and we get A is 0.05 or 5/100ths. Go back and fill in for our actual equation. We have y is equal to 0.05 times x minus 6 times x minus 21. So if you can try to keep in mind that when we're writing an equation for somebody to be able to graph something, those equations need to include x's and y's when we're done. So we can't stop at just finding out what the A value is. Remember, the A value is your stretch or your shrink. We also need to know then what the general equation is so anybody can use it. That's it for these notes and for this chapter. We'll see you tomorrow.